Hello students, how are you all? I hope all of you are doing amazing. So welcome all of you at AriserTalent, and in the chapter that is matter around us pure. In our last lecture, we have a discussion about the separation techniques, and we have discussed the separation techniques of solid and solid. Now in today's lecture, we are going to cover our next part, that is separation of liquid and liquid. Then we will continue with separation of gases from the air. So our today's lecture is all about the separation of liquid and liquid. So if you want to separate two liquids, there are basically two methods. First one is by using the distillation, and the second one is by using the separating funnel. So let's start with the topic here, that is about separation of liquids. So if we are going to separate any of the two liquids, what you have to do, you have to heat the liquid, so you will obtain the vapor, and if the vapor are once cooled, you will again obtain the liquid, and this process is generally known as the sublimation you have. Okay, so in sublimation, what you have to do? So separation of the liquids can be done by performing the process that is known as distillation. In distillation, you have to heat the liquid and you will get vapors, and if you cool the vapors, you will again get the liquid. So this process is known as distillation. So there are two methods for performing the separation of two liquids. One is distillation and the second one is by using the separating funnel. So the two basic methods are by performing distillation, and second one is by using separating funnel. Now, the first part is all about distillation, and in the distillation you have the two categories, that is the simple one and the fractional distillation. But before that, just simply write the definition of the distillation. So distillation is actually a process in which the liquid is heated to get the vapors, and if you cool that vapors, you will again get the liquid. Clear? So it is the process in which liquid is heated to get vapors and vapors are cooled liquid. Clear? So liquid is being heated to get vapors, and if you cool that vapors, you will again get that liquid. Clear? So it is a process which can be reversed, and this process is actually known as distillation. So a question arises from here, explain distillation with example. Now if you are performing the distillation for separating two liquids, you have to perform two distillation here, that is first one is about the simple distillation and second one is about the fractional distillation. So in the category of the distillation, the first one is simple distillation and the second one is fractional distillation. So we have to deal with these two major categories here, that is about the simple distillation and fractional distillation. Now what is simple distillation? If I am saying that I am dissolving salt in water, what you will get? You will get the salt solution there. But if you want to separate this salt from water, you have to evaporate it. So simply what we will do, we will just perform the distillation here, and we are performing the distillation because two things are miscible in each other and there is a difference in the boiling point of both these substances. Clear? So for separating the salt solution, for obtaining the water again from that, you will perform a simple distillation. So let us see what will be the setup for performing simple distillation. So the first part is all about simple distillation. So in the process of simple distillation, firstly we will take a tripod stand here. And there is a burner situated here. We have to put a and there is one clamp stand for holding it. Now this is a complete setup which is going to show you that how you are going to perform the distillation, simple distillation. Now what we have done, we have just taken a tripod stand and a Bunsen burner, and we have kept a conical flask over it which consists of salt and water solution. Salt dissolved in water. So I am just pouring in this conical flask salt solution. Clear? And from this we have simply placed a thermometer here. So time to time we can check the temperatures here. So we have to identify the boiling points here majorly. So this is a thermometer we have placed for measuring temperature. Clear? This is our conical flask. This is our Bunsen burner. Here it is a tripod stand. Then what we have done, we have just taken a something here that you can see here. This is the part what we have taken here. And in this part what you are provided with one inlet and outlet. So here it is an inlet and this is the outlet. So this is an inlet which is basically used for pouring water. So inlet and this is outlet. Now this glass tube that we have taken is actually a water condenser and it is known as Liebig's condenser. The name for this condenser will be Liebig's condenser. Liebig's condenser, and it is actually a water condenser in which a glass tube is surrounded by a white glass tube which is providing you for water for inlet and outlet. So this is known as the Liebig's condenser. So this is Liebig's condenser you have. Now from this condenser you can see that it is given a support by using the clamp stand here, and from this condenser what you are getting, after providing the water for inlet and outlet, you will provided a distillate here. So distillate should be collected in this part here. So you can get that in this part you will get the distillate. So this is an activity which is showing that how would you perform a process of simple distillation. So for this you will be going to take the Liebig's condenser. Liebig's condenser is actually a water condenser in which a glass tube is surrounded by a white glass tube, and there is a system for inlet and outlet. And what will happen in this, the inlet part, the outlet part is having a water which is a cool water, and inlet part is having a water which is in hotter form. So the water is going to take vapors from the hot water and the process of condensation keeps going on, and after the last in the last step what you are getting here, you will get the distillate here because you want to separate the two miscible liquids here. Clear? So this is a process which is actually accompanied for the separation of two miscible liquids having a difference in boiling point which is quite high. Clear? Now simple distillation and fractional distillation are very different from each other. In fractional distillation, you have to take a fractionating column, and this is you want to separate the two liquids which is having a difference in boiling point, but the difference should be less than 25 degrees Celsius. If I am considering the ethyl alcohol and water, there is a difference in their boiling point, and this thing will be separated only by performing the fractional distillation. But for simply sorting the two components here, you can use the simple distillation here. So just copy this part from here. Now the next thing is all about the fractional distillation. So the next process will be fractional distillation. Fractional distillation is actually a process of separating two miscible liquids which have the boiling point difference between them, but the boiling point should not exceed 25 degrees Celsius. It must be less than 25 degrees Celsius. So it is a process of separating two miscible liquids. It is a process of separating two miscible liquids having difference in their boiling point. If two liquids are having a difference in their boiling point, you can separate them only by the process of fractional distillation. Now, I am going to separate ethyl alcohol from water. Water is having a boiling point of 100 degrees Celsius and ethyl alcohol is approximately having 78 degrees Celsius. So the difference is almost 22 degrees Celsius. So it can be separated only by the process of fractional distillation here. So what we are doing? We are considering the separation of water and ethyl alcohol. If we are separating water and ethyl alcohol, we know that water is having a boiling point of 100 degrees Celsius and ethyl alcohol is having a temperature boiling point of 78 degrees Celsius. So if you want to go to separate these liquids, you can have a temperature must be approximate in the range of 25 degrees Celsius. So if I am going to subtract these two factors, I will get 22 here. So this can be separated by using the fractionating column. Now what will be the setup for the fractional distillation? I am drawing here. So just copy this part. So similarly in the fractional distillation, firstly we will take a tripod stand. In that tripod stand we have used a Bunsen burner. For heating the liquid we have taken a conical flask. So this is a complete setup which is showing that how we are going to perform the fractional distillation. So for the fractional distillation, again we are doing the same setup, but what the difference between them is here. Here we are taking the fractionating column. So we will get the vapors of different substance at the different boiling points. So for this purpose, we have just taken a clamp stand here. This is clamp stand. Then we have taken a tripod stand. Here we have taken a Bunsen burner. In this we have taken a mixture of ethyl alcohol and water. So in this container or in this conical flask, I have taken a mixture of ethyl alcohol and water. So this is basically a mixture of ethyl alcohol and water. Now we have taken a fractionating columns here. You can see that this is a fractionating columns, and here we have used a thermometer which is going to tell you the boiling point at a different levels. ठीक है? So this is about the thermometer. And this is what? This is the fractionating column we have taken. This is a fractionating column. This will consist of low volatile vapors, and this tube will going to consist of the high volatile vapors. In this part, you will get the low volatile vapor. And in this tube, we will collect the high volatile vapors. So, low volatile vapor is going to be collected in this section, you can see here, and high volatile vapor is going to be collected in this. As it is consist of thermometer, it will going to measure the temperature and the vapor is going to be collected here. So, it will consist of the high volatile vapor. Then what we will do, we will attach the whole system with the Liebig's condenser, which is actually a water condenser. So, from the similar setup, what we have done, we have just attached this with a clamp stand and we have taken a Liebig's condenser here. This is Liebig condenser, which is actually a water condenser. And in the Liebig's condenser, we have seen that there is an inlet and outlet for a water. So, this is inlet from which the water is poured, and this is the outlet for water. So, this is the whole setup which is showing you the fractional distillation. Now, you can see that in this container, you will get the distillate, it means ethyl alcohol, which is separated by the water. So, you can see that you will get the distillate here. So, this is the whole setup we are performing for fractional distillation. So, one thing we have to keep in your mind that first thing is, for the fractional distillation, there is a difference in the boiling point of the both substance. The two substances will be miscible with each other. So, you can separate them by using the fractionating column. So, this is a huge difference between the fractional distillation and simple distillation. And again, what will be the Liebig's condenser do? It will provide the cold water from the outlet, and in the inlet section it is having a hot water which is going to condense, and finally you will get the distillate here which is collected in a separate pot. Clear? So, this is all about the fractional distillation. Now, we have to discuss the next process, that when the liquids are immiscible, it means one liquid is not going to mix with the another, how you will separate them. But before that, copy this from here. Next one is about the separating funnel. The second process is separating funnel. Have you ever observed you can mix kerosene with water? What will happen? If you have not done so, just do it by having a simple activity. Just mix kerosene and water. if you mix kerosene and water, you can see that the kerosene is not going to mix with the water. Similarly, if you are mixing benzene with water, you will not get this perfect solution. The benzene is going to float on the surface of the water. So these are two immiscible liquids. So two immiscible liquids can be separated only by the use of separating funnel. So separating funnel is actually a funnel which is used to separate two immiscible liquids. Two immiscible liquids can be separated by using separating funnel. Okay. For example, if I am separating kerosene and water, so kerosene and water can be simply separated by the use of separating funnel. So what you will do to separate this kerosene and water, just take a separating funnel here. So this is a diagram which is showing the separating funnel. What we have done, we have just used a clamp stand to hold this funnel. So this is actually a separating funnel we have. In this funnel, what we have taken a kerosene mixed with water. What I have poured here, this is a kerosene mixed with water. So in this funnel, we have taken a kerosene plus water. Now, if you keep pouring kerosene and water in this separating funnel, what you have to do, you have to keep it undisturbed for some time. You have to hold it in a fixed position and do not disturb it until 2 or 3 hours. After 2 or 3 hours, what you have observed that from this separating funnel, if you placed a container or a beaker below it, you will see that the kerosene is going to float on the surface of the water. Because the kerosene is having a density little bit high than the water, it is going to float on the surface of the water and you will get the clean water at this bottom part of the container. Now, if you use filter, if you are using the filter, you can separate the water from it and the leftover part is the kerosene you have. So, when you keep it left undisturbed for few hours, you can see that drop by drop, the liquid is getting poured in this container and you will get an upper layer of kerosene and then water in the next part. So this is what this orange colored layer I have drawn is kerosene floating on water and this yellow colored part is our water. So now by just using simply the filter, or you can see that the filter anything you can use for separating this kerosene and water. So this is all about the separation of liquid from liquid. So this lecture is all over for today. We will deal with separation of gases from air in our next part. Thank you so much.